Okay, so welcome to the 2011 Section A DCG question A1 on higher level work. So we have to do this question here in the atom. So the 3D graphic below shows a molecule of methane. The 4 outer atoms shown in red are located at the vertices of a tetrahedron. Okay, so here we have a tetrahedron, so made up of 4 equilateral triangles. The drawing on the right shows the projection of a regular tetrahedron without the spheres. Draw an auxiliary plan on the given x and y1 line. So an auxiliary plan is always projected from elevation to show the dihedral angle between the planes ABC and ABD. So the dihedral angle is the angle of intersection between two surfaces. So here we have here. So I'm going to show the angle between this surface here and that surface there. So I'm going to project down along that line in elevation, that line there, the line of intersection. It'll appear as a point because it's a true length in elevation, and the reason it's a true length is because the line is parallel to the XY line in plan, parallel to the vertical plane. So when I look down along this line, when I project from my elevation down along that, that's going to appear, now it won't work perfectly here in the computer, but those two faces, okay, appear as edges. So this face, it appears as an edge there, and that face, this face, yeah, this face here appears as that edge there. Okay, so I'll begin. So I'm going to line my set square up with the x1 y1 line, and I'm going to project from my elevation. So I'm going to project down from my elevation, and in an auxiliary plan you take your distances from your xy line to plan. So I'm going to just continue these lines here. And now I'm going to take my compass, put my compass on the xy line, bring it to D, lift, follow D along here, mark D in from the x1 y1 line, so that's D1. Put my compass on the xy line to do point C, bring the nib down to C, lift, follow C from here, mark it in there, that's C1, then A. So put my compass on the xy line directly underneath A, bring the nib to A, lift, find A along here, and mark it in there. So that's A1. And then the same with B, put your compass on B, on the xy line, bring the nib down to B, lift, mark it in there. And you see they're on the same position because line A to B appears as a point view in your auxiliary plan because you're looking along its true length here. So I'm going to join A1 to B1, and A1 to C1, and there's the dihedral angle. It's always good to measure that. I don't know where I put my protractor though. That's typical of me. I think the angle might be 70 degrees. Here we go. So the angle is here. So yeah, angle is 70 degrees. So the green surface appeared as an edge there, and the red surface appeared as an edge. Now we have to draw the projections of the largest possible sphere that can be contained inside the tetrahedron. So we'll bring up a model here. Okay. So there's a sphere that sits inside it. The biggest possible sphere that can be in it is one that is a tangent to this face. So it's a tangent to that face and a tangent to the base. Alright, and I'll prove that there can be no bigger sphere. Just while I'm at it that's how to find the centre. I bisect the angle by using my compass to swing arcs, and I draw the bisector through and drop the apex down. Where they intersect, that's the centre point of the sphere. Now I'll prove to you that we can have no bigger sphere, okay, because if I bring the radius up, you can see there, it's going to cut out there. Right, so I'll do this on the drawing. So I take my compass, I set my compass to any angle, the bigger the better. Okay, I'm going to swing an arc on both branches of the angle. Lift your compass, don't change your radius, swing an arc here, and swing an arc here. Now, that's the bisector, so join that back to point CD. And now, where that crosses the line coming down from the apex, straight down, that's the centre point for the sphere. I think I'm just going to adjust mine a little bit there. See, mine was a tiny bit out there, so it wasn't, but that won't have affected my auxiliary, as they're still equidistant. Okay, so I'm going to set my compass here. So I can draw in the sphere. And the radius of the sphere remains the same in plan. It's just under where point A is, directly underneath. Okay, and it's going to be hidden detail, as you can see here. It's represented by hidden detail in plan and. So there we go. Cheers, thank you, bye bye.